Hey, scientists! I really enjoyed coming out to your school the last few days. So today we're going to do a new lesson on energy transformations. So go ahead and take out your science journal, and we're going to write this on the top line in the center. So make sure you capitalize the E and the T and underline it. So we're going to start this with a think about it question. So my question to you is there more energy today or 165 million years ago when dinosaurs roamed the earth? So why don't you go ahead and think about that, have a discussion, and I'll be back with you in a minute. Okay, so what'd you come up with? Was there more energy 165 million years ago, or is there more energy now? Well, let me tell you the answer I usually get. Most people say there's more energy now. And the reason they say that is something you probably came up with too, is we look at all the electrical energy we see now, which of course didn't exist 165 million years ago. You see all the buildings with lights, and then you have your cell phones and your computers and whatnot. But the answer is actually there's the same amount of energy. While there's more electrical energy, energy existed in different forms back then. It just simply changed from one form to another. So that kind of leads me into the next thing that we're going to talk about, and that's the law of conservation of energy. And what that says is energy cannot be created nor destroyed. It simply changes from one form to another. Now, you don't have to write this unless your teacher tells you to. It's just something I want to discuss. So back then, there was a lot more potential energy, which we really didn't talk about, but there was a lot more chemical energy back then. And what it did is it changed forms and it moved into electrical energy, and many other forms as well. So that's what we're going to talk about today. We're going to talk about how energy changes from one form to another. Okay, so let's go ahead and skip a line in our journal and let's write the definition of energy transformation. So, energy transformation, write that word, underline it, and put when energy changes from one form to another. Okay, so I have a flashlight here. Let's talk about the energy transformations for a flashlight. So where does a flashlight get its energy? Where does it start from? That's right, the batteries. So there's batteries in here. And what kind of energies does batteries have? Well, we talked about this. It has chemical energy. So the chemical energy in this flashlight is going to change. So in the middle of this flashlight, there's wires. So what kind of energy do you think goes through the wires? Electrical energy. Then the electrical energy is going to transform into light energy. So it goes chemical energy to electrical energy, and then that changes into light energy, which is what you want from a flashlight. So let's go to our notebook and put this in our notebook. Okay, so go ahead and write energy transformation for a flashlight. And what did we say? Where did we say the energy would begin? We said in a battery. So let's go ahead and draw a diagram of a battery. See my picture? I drew that. Obviously, it's clip art, but I'm sure you could draw a simple little picture of a battery. And then we said the energy from the battery went to the wires. So draw a simple picture of wires. And then we said that that transformed into light energy. So I'm just going to draw a picture of a flashlight with emitting light energy. There's space that out, right? Now, the way that you signify energy transforming from one to another is you put an arrow. So I'm going to put an arrow between the battery and the wires, and then I'm going to put another arrow between the wires and the flashlight or the light energy. Now, of course, we have to label. So go ahead and bring your words. So go ahead and put your words. We said a battery has chemical energy. And then we said there was the wires had electrical energy going through them. So label your wires as electrical energy. And then we said the flashlight, that what we wanted from a flashlight is light energy. So that's how your diagram should look right now. So again, the chemical energy in the battery changed from electrical energy into light energy. So just going back to something we said before, when we had the battery dies, is that energy destroyed? No, it's not destroyed. It simply changed. It went from chemical energy into electrical energy, into light energy. So energy was never created. It started as chemical energy, it went into electrical energy, and then it went into light energy. All right, so why don't you go ahead and get caught up on your notes, and I'll be with you in a moment. All right, so I have an electric pencil sharpener here. I'm going to go ahead and plug it in, and I'm going to sharpen my pencil. All right, so what's the energy transformation for an electric pencil sharpener? So what's the beginning of this? Is it chemical? No, it's not, because it's not a battery. You have a cord, remember? So if it has a plug on it, it's electrical. So the beginning of our energy transformation is electrical energy. Now, what do you want from a pencil sharpener? I know we heard sound energy, but do we want sound energy? Is that why we bought the electric pencil sharpener? No, we did not buy it for sound energy. Sound energy is actually a wasted energy. We got it. We're paying for some of it from the electric company. However, it's not an energy that we want. What do we want? Well, we want mechanical energy. Mechanical energy, when I put the pencil sharpener inside, what's moving? Well, there's razor blades and there's gears and whatnot all moving. So it's electrical energy to mechanical energy. So let's go ahead to our science journals and update it. All right, so like I said, we have our electric pencil sharpener. I have a picture here showing the plug. So we're going to begin with electrical energy. So go ahead and write electrical energy. And then remember, we use an arrow to signify a energy transformation is about to happen. And now we're going to go ahead and put mechanical energy. So electrical energy to mechanical energy. And remember, sound energy, if you wanted to write it, you could write it off over here, but it's really not necessary. You go with the energy transformations that you see, and the one at the very end, it's the one that you want, and that's the most important one. On an electric pencil sharpener, the gears are spinning, the razor blades are turning, so both of them are an example of mechanical energy. All right, so we have energy transformation for an electric heater. So go ahead in your journal and write electric heater, maybe draw a simple picture, and put the energy transformations. Don't forget to put the arrow in between to signify an energy has changed forms. All right, so what did you put? Well, it's an electric heater. You know that because I wrote it. Plus, this one has a cord coming off of it here. So we start with electrical energy or electric energy. Then we put our arrow to signify an energy transformation has occurred. And then I'm going to put heat energy. That's the obvious one. So electric to heat energy. But you could have put other things as well. You could have put thermal energy. And what's that R word we discussed? To heat through air? Yes, radiant energy. You could have put radiant energy as well. So any of those words here would be fine, but it's an electric heater. It starts with electrical energy, and then it transforms into heat energy, thermal energy, or radiant energy. I think you guys are getting the hang of it now, right? All right, for the last one, I figure we'll go back to one of the ones that we built while I was there. So here is a circuit with a buzzer. So this one, I would like you to put three energy transformations. Well, two transformations, three different words, blank to blank to blank. So go ahead and give it a shot, and I'll be back with you in a minute. All right, so where did this circuit get its energy from? What's the beginning point? Well, it's the battery. And what kind of energy does the battery have? You know it. We've talked about it a lot. It has chemical energy. So write chemical energy there. Then we then it's going to change. Now it goes from the battery into these wires. So what kind of energy is in the wires? Yep, electrical energy. So chemical energy to electrical energy. Draw your arrow. And now what do we want from a buzzer? Well, this time before I mentioned that sound energy is a wasted energy. Well, it's only a wasted energy if it's not what you want. In this particular case, we want sound energy. So this is the energy of vibrations, sound energy, and there you go. All right, everyone, that concludes our lesson on energy transformations. So I hope you enjoyed it. Get ready. There's a Kahoot game tomorrow, and then you have your test. Take care.